So would you consider it a hot start now or not?
Nah.
You're right in between, so your guess is as good as mine. That's why I'm glad you're running it, not me.
Yeah.
This one is all about propellers.
If we wanted to check the sensitivity, and we'll take a dollar bill and we'll see if this is enough weight to actually change the reading on the machine. And that's how sensitive the machine is. Literally a dollar bill is enough to throw the balance out.
Clear prop.
We've got all access behind the scenes at Hartzell to learn about static and dynamic balancing, design and manufacturing, and the testing that goes on here.
What we are measuring is not what you would consider a balance vibration. It's inherent to the harmonics of the rotating system.
So right now we went from 1/4 inch of movement per second to 30 thousandths of an inch of movement per second.
After finally getting the VFR only restriction removed,
Forgot to plug in my intercom, but I got cleared as filed, so it wasn't really very exciting.
this was the first time filing IFR for a trip in the RV-14. There was a service bulletin out for the prop, and I had an open invitation to visit the factory. So this was a perfect opportunity to fly to Hartzell in Ohio, and I captured the entire flight, which I'll be sharing as a dedicated episode. Immediately after I landed, the technicians got to work.
Here at Hartzell Field, customers can fly in, have their props removed for service and overhaul. We do things like dynamic balancing here, and we've got the service bulletin that we are going to perform on your airplane. Just a handful of these Raptor propellers that this affects. It's nice enough that you were able to come down.
You might recognize Chris from the remote interview that we filmed during the build vlog.
Thanks so much for working with the FlightChops team. So I'm going to be cutting a scene of us unboxing it. I love the crate. It was very exciting. That was definitely the most unique crate we've received for the whole build.
Cool.
And now I'm here, in person, ready to learn about one of, if not the most established propeller manufacturers. I'm proud to be working with them, and the first person I met here was Steve.
We have a fantastic workforce here at Hartzell with hundreds of years of experience that we're putting into the Built on Honor motto every day to ensure that not only is your flight enjoyable, but that it's safe. Hartzell was founded in 1917. We have a display here of Hartzell and how we got our start. We had a Hartzell family that was very involved in the wood business. Of course, Dayton being the home to the Wright brothers. We had a company founded on the basis of what was then military projects and aircraft manufacturing by the Wright brothers. We are involved in a lot of different segments of business.
But I'm not just here to see how things are made at the factory. After the service bulletin was completed and the static balance was done,
So I'm good to just fire it up? Yeah, they're coming up.
we did the dynamic balance for the RV-14's prop, which was the final stage before I headed home on day 2. The airplane's rigged up with some pretty high-tech equipment. It's wired up so they can plug in the monitor to these cables, and this thing is some sort of a light sensor or gun, and there's this reflector on the prop, which is how it senses it, and all the data goes to this monitor computer console thing. We have the tail tied down as well as the airplane chocked. The initial run, I needed to get it up to oil temperature before I could do the run up to the 2400 RPM. When I gave the thumbs up, they saved the baseline numbers, told me to shut down, and then the process continues with tweaking teeny tiny amounts of weight and then running it up again and seeing what the changes were. So we'll keep coming back to check in on this process as we move through the rest of this episode.
This is our main manufacturing facility. We also have the composite manufacturing building, and then we have a research and development facility where we're doing some of our engineering tests, but the majority of the manufacturing processes are taking place in this facility. One of the things that Hartzell has invested in heavily is robotic technology, where we can have a repetition of parts and also quality. It's very important that we're making parts the same way, that the quality is the same, and robotic technology helps us to to make sure that we are providing the best and the safest components possible for you to fly on the front of the airplane. Hartzell Propeller manufactures and services over 4,000 propellers a year. That's our current count. You're going to see some very precise, what we refer to as CMM machinery, a coordinate measuring machine. And these machines are highly accurate. They're very accurate. We're measuring in many cases to the 10/10,000ths to 100,000ths to make sure that the parts actually are repeatable, but also that they meet the drawing and the print requirements. Here are some examples of the forgings that we utilize to machine and manufacture our aluminum blades. And what's interesting about this is that we have, I'm not sure how many we're up to now, but it's like 8 or 9 maybe forgings, I believe, that we're using to actually machine over 600 different blade designs. So this particular robot now is going to go through the process of actually picking up our blades and then placing those blades into the various machines in order to go through the manufacturing process. A multi-axis mill is actually going to cut the airfoil for both the face and the camber side of the blade into the blade. You can actually see the machining marks from where the cutter heads have gone across from lead to trail and trail to lead. In the past, these machining marks were removed by hand. The question now is how do you remove those machining marks? If you're not doing it by hand, how are you doing it? And that's our next robot. This particular robot then is responsible for actually grinding off the machining marks. They'll also go through several steps of polishing. When the blades are finished, the blades will come off the line. And you can see here that we have some red lines. Those red lines reference various stations on the blade. And those various stations have to be inspected for minimum width and thickness, and also the airfoil and also blade angle. This room is our penetrant inspection room. This process involves basically etching the part, washing and cleaning it, putting it into a dye tank, and then removing it from that dye and then putting it through a developer tank. And that developer will actually remove or pull out any fluorescent dye that may have seeped into a crack or a forging lap. And then when we're done in a stride, we do the inspection under black light. So what we're gonna do is we're gonna turn the lights off here, and hopefully your camera will be able to pick up what we'll show you. But we've got a test piece here which will show you what a crack would theoretically look like in the event that we found on the production line. How many parts a year do you find where we actually have a problem? 1 or 2 in a year's time maybe, where we actually have to reject a part.
Of course, alloy propellers are not the only thing Hartzell produces.
In the past, the lion's share of propellers were with aluminum blades. And now what we're finding is that that's starting to switch, and what we're finding is more and more applications utilizing composite technology.
The composite side of the industry is growing, and this dedicated building was really cool to get access to.
As you look through the stations, you can see the manual processing. What we do in here is we pick all the raw material, the lead edges, the foam core, the carbon material. They create a kit, and once they have the kit, they go to their bench and they begin starting the layup process. From an engineering standpoint, they've designed exactly how each layer goes on, whether it's 45 degrees versus 90 degrees or 0 degrees, and that's the process that's somewhat secret, if you will, or proprietary.
They look all complete, but then they also go get cooked.
Yes, and we have another furnace right on the other side of this wall. The molds do need to be at a certain temperature before you put the blade in it, so we keep them warm. We are, I'm going to say, somewhere in the neighborhood of 50 or 60 blade designs. We have 8 presses right now that we run all the blades in.
So this blade that's being born here is almost the exact same model of the ones that I'm running on the RB14. And it's really cool to see this massive heavy mold getting peeled open to reveal it. Back outside, progress is being made with the dynamic balance.
Legs off.
After taking the baseline readings during an initial run-up, the crew identified precisely how much weight needed to be added and exactly where to place it.
So right now, we zeroed the scale with the spinner screw and then you measure out your weight. So you got 13.1 and one's 13.17 grams at 340.5 degrees. And here we have a template with where our spinner screws are, which is where we can add weight right now. We can add weight at 340, so that's what we'll do.
So initially they use weighted screws on the outside of the spinner.
And that weight also has the weight of the spinner screw included in it.
Okay.
And then when we're all done, we'll move it inboard of on the bulkhead inside the spinner. This machine has a capability of splitting the weight, so we can say, okay, we want to add weight at 190 and 220, and it'll calculate that for us. So it's
cool. All right. So
it makes it pretty easy.
So we're gonna fire it up again with that weight added. Okay. Won't be as long waiting on temps this time. So would you consider it a hot start now or not? It's not really super temp yet.
You're right in between, so your guess is as good as mine. That's why I'm glad you're running it, not me.
Yeah. Clear prop.
So the key here is to get it to the exact cruise RPM that we desire, which in our case is 2400. Having lever engine controls as opposed to vernier knobs makes it a little bit more difficult to be precise, but I took my time and got it where I needed it. We'll check back in to see what tweaks were required after the second run in a minute. Hartzell recently acquired Tanis and they wanted to show me this engine preheat system, which I highly recommend as a cold weather operator.
Okay, this is a Tanis preheat system for a 4-cylinder Lycoming engine. This will heat the entire case, heat the air coming in and fuel mixture coming into the cylinder for a better start in the wintertime. When it's really cold, your oil, it's so thick it doesn't want to flow through the engine as fast, so your oil pressure is going to be low until it finally picks the oil up, where thinner warm oil is going to circulate through your engine faster. It'll heat the entire case and heat like all your oil galleries. You have your oil galleries running down both sides of the engine case. Your oil's warm, the engine case is warm, and your cylinders, so essentially you're heating the entire engine.
So yeah, knowing the temperatures we were up against, a preheater was installed on the RV14 during the build. And Hartzell was proud to show me the facility that manufactures their de-ice and anti-ice boot lines.
So in this area is where we do our first operation, which is the fly cutting operation. And as part of the fly cutting, we will bring the neoprene out. And the neoprene has predetermined patterns. And we'll nest the patterns within the material here. And then we'll go ahead and just fly cut it to get all of our shapes. So here's the example of a boot that has been finished and cured. Then we will terminate them based on the configuration that it's going to go in.
And for quality control, they're using an X-ray machine to make sure everything is in place inside the boot. We got a lot done on day one, and toward the end of the afternoon, I was reunited with my prop.
So this is your propeller after we complied with the service document. So now that we've performed that process, we want to put it on the static balance machine to ensure that the balance is correct for this particular propeller. Steve, this is our blade balance room. In this particular case, what we're doing is we're actually balancing the blades individually to each other. This is similar to balancing a tire on a car, only in a horizontal plane instead of vertical. The machine is calibrated, and then what we're looking for is a light that signals in the green that the propeller has in fact been statically balanced. We're measuring it at 360 and 180 degrees just to confirm that the balance is good in both planes. If we wanted to check the sensitivity, and we'll watch those numbers here, and I'm actually going to take this dollar bill, we'll see if this works, but we'll take a dollar bill, US dollar bill, and we'll see if this is enough weight to actually change the reading on the machine. So we'll put it was about 196.03, and you can see now that I don't have a green light, but what I actually have is a change on the machine in terms of how much weight that I have to actually add to the other side of this propeller assembly, and that's how sensitive the machine is. Literally a dollar bill is enough to throw the balance out. The benefit of this is when we go to do the dynamic balance, we should be able to bring the rotational group into balance much better than we would if we had a level of static balance, which might not have been as accurate.
Let's let the machine go back to normal.
And you can see it went back to normal and we have the green light.
From static balance back to dynamic balance. Let's see how close we got.
Eggs off. What do you think?
So we're at 0.3 and we actually added weight and our goal is to get real close to the center. We actually went past a little bit. So we're going to hit our remove previous weight and it'll recalculate and we'll have a lesser weight in that location. So right now we went from 1/4 inch of movement per second to 30 thousandths of an inch of movement per second.
Wow, that's crazy.
And this ought to make it better.
Okay. And then we're gonna run it one more time after this adjustment?
Yeah, one more time.
Yeah, okay.
Before it went at 13.2 grams, now it wants 11.5 grams.
So we're taking 2 grams off.
2 grams, wow. How'd they do this in the old days?
This is really kind of the same as when you buy tires for your car and they speed balance it.
Right.
Except you're balancing kind of the engine, prop, and spinner all as one unit.
Yeah, that is what's nice about dynamic balance. I mean, it's statically balanced at the factory, the prop.
Yeah.
Gets
You
it
know,
close.
but then as a combination, the airframe, engine, prop together is what a lot of times people will say, well, it's statically balanced, right? And it's like the dynamic balance, you know, kind of puts it all together and
Oh, yeah.
it's the whole
In context.
whole machine smooth, right? Exactly.
Yeah.
Another aspect of the testing they do here kind of blew my mind.
We do a lot of testing of our products. Part of that testing is testing for engine propeller vibrational compatibility. And when we say vibration, we're talking typically about very high frequency vibration that the prop is experiencing, rather than the vibration that you're going to feel in the airplane cabin. We need to make sure that it does actually handle those stresses. With all of the different strain gauges that we have put on the critical locations on the blades. So we've got some tip gauges, we've got some mid-blade gauges, we've got some shank gauges, there's a couple gauges in the hub. Basically put the system through its paces and make sure that the prop isn't experiencing anything that's harmful.
Are these like accelerometers or whatever?
They're strain gauges. It's a small electrical device basically that generates a difference in resistance based on how much it bends.
How much it bends. So what's it measuring bend like?
So a composite prop, it's measuring strain. Basically it's measuring how much the individual fibers underneath here are moving apart from each other or closer together.
So if you test metal props, it's a different deal.
It's measuring a similar thing, but we're measuring stress in that instance rather than strain. What we are measuring is not what you would consider a balance vibration. It's inherent to the harmonics of the rotating system.
You know, it translates into certain things that you do have to think about when you're selecting a propeller. That's the beauty of experimental and what you're doing with experimental. So how do we best educate the builders and the owners and have an open dialogue to be able to talk about it?
We have a passion for aviation. We have a passion for experimental aviation. A lot of us are home builders ourselves. We want to make sure that if you're using our products, you're making that choice informed.
Ready for me to strap in? Or not strap in, as it were?
So yeah, that vibration testing scene alone was 20 minutes raw, and I've included that for Patreon supporters. And there's also a raw version of the static and dynamic balance scenes available for supporters.
Clear prop. Cool, so that got it?
Yep.
And these are the final numbers that we landed on. It was 0.021 IPS, which they were very happy with, so I'm impressed with that. It's super smooth now. And that's the weight on the inside of the hub, and you can notice the index mark they made on the bulkhead, which lines up with the spinner, because obviously that's balanced as well. So So I hope you enjoyed this one. I definitely knew propellers were complex, but this trip was a real eye-opener. And thanks to everyone at Hartzell for letting us in to share the process behind the scenes.
This is our final assembly area. As these parts come to stock, all of these technicians have to understand how to assemble all these various models, and they're very, very good at what they do. There's a lot of sophistication that goes on in this, and I don't think we give these guys enough credit. I'm celebrating my 27th year this year with Hartzell, and it's been an amazing career and an amazing journey, and I've been very blessed to be a part of this workforce, no question.
And until next time, keep your FlightChops sharp.
Wow, this is like way more than I thought I'd learn about this stuff. That's very cool. Let's get some close-ups to this. Or did we miss anything else that you want to say about that stuff?
Probably.